Hello viewers, welcome back to my channel. Today we shall be talking about elementary kinematic properties of flow. When we talk about the word kinematic, what do we mean? It means dynamic, it means kinetic, it means mobile. So we want to look at those properties that lead to flow of a fluid. That's just a summary of what we are referring to. Let's quickly look at what those properties are. The elementary kinematic properties of flow include shear, curvature, confluence, or you call it diffluence, contraction, or you call it stretching. Their SI unit is in per second. We are going to look at their mathematical definition in terms of the natural coordinates, and from there, we are going to be able to define them mathematically and also verbally. Before we continue, these are some mathematical expressions and their meaning. The dv here simply means the change in velocity. So anywhere you see dv, you define it as the change in velocity. Where you have the psi, the change in direction. The n, transverse direction of the flow or motion. The s, downstream direction. So anywhere you see the v over the n, you define it as the change in velocity all over the transverse direction of the flow. The v over the s is talking about the change in the velocity in the downstream direction. When you see the psi over the n, will be referring to the change in direction in the transverse direction of the flow. Then where you see the psi with the s is the change in direction in the downstream direction. So that is just what the combination we are going to use in order to define these properties of flow, elementary kinematic properties of flow. Okay, let's go down to the table. The first one is shear. In natural coordinates is defined as dv over the n. So the shear there is simply defined as the rate of change of velocity in the direction transverse to the flow. The rate of change of velocity, dv, in the direction transverse to the flow. They all have the same SI unit per second. The negative sign means that the shear moves in a counterclockwise direction. What do they mean by counterclockwise? Anti-clockwise direction. So that is the definition for the shear. We now move down to the next one, which is the curvature. Whenever we talk about curvature, it has to do with bending. Okay, so we have the psi over the s, which is defined as, v the psi over the s, which is defined as the rate of change of direction of the flow in the downstream direction. The rate of change of direction of the flow in the downstream direction, SI units per second. Then the next one is the confluence. You can as well call it diffluence. So whenever we talk about confluence, it has to do with the convergence of fluid. It has to do with a junction where fluids do meet, a meeting point. Okay, so confluence or diffluence is written in terms of natural coordinates as v the psi over the n, and this can be defined as the rate of change of direction of the flow in the direction transverse to the motion. The rate of change of direction of the flow in the direction transverse to the motion. SI unit is per second. It is positive if the streamlines are spreading apart in the downstream direction. Let's go to the next one, contraction, or you call it stretching. Contraction, or you call it stretching. If we don't call it contraction, you can call it compression. So in this case, this is one of those kinematic properties of flow. Stretching, contraction, compression, and all of that. It is defined in terms of natural coordinates as the v over the s, which is the rate of change of speed, or you can say the rate of change of velocity of the flow in the downstream direction. The rate of change of velocity of the flow, dv, in the downstream direction. Okay, so we now move down to the next one here, the vorticity. Vorticity has to do with rotation of fluid. The rotation of fluid. If you look at what we have here, it is the measure of the local spinning motion of fluid. So it has to do with the spinning motion of fluid. We can as well define it as the sum of the shear and the curvature. So if you look at this mathematical expression here, you have the psi over the s and the v over the n. The v over the n here represents the shear, while v the psi over the s represents the curvature. When you add two of them together, you get this. But here we have curvature plus the shear. But the minus here is as a result of the fact that the shear was negative, and we don't expose negative sign in mathematics, so you now shift it in. But these two expressions tells us that we are adding shear and curvature to get vorticity. Okay, so the next one is the divergence. The divergence is simply the sum of diffluence and stretching. The sum of diffluence and stretching. So that is just the summary of what we have here under the elementary kinematics of flow and their definition. So the next thing we would do in our next class is to go into how to solve mathematical problems on this topic. Thank you very much. If you have enjoyed our class today, I want you to go down to our channel and then click on the subscribe button. Thank you so much, and I hope to see you in our next class. Have a wonderful day.